You spend years and millions of dollars perfecting the micro tolerances of a machined component. The metal leaving the factory floor is pristine, but all that precision and engineering remains highly vulnerable to raw environmental exposure. During a long ocean transit, steel shipping containers cross multiple climate zones. Warm, humid air gets trapped inside the box. When the external temperature drops at night, that trapped moisture hits the cold steel ceiling and condenses. The container literally rains on the cargo. For frontline logistics operators, the immediate aftermath is devastating. 6 weeks after shipping, the client opens the doors to find the cargo completely corroded. You are left holding a rejected shipment, while spending weeks fighting insurance adjusters who deny the claim under inherent vice clauses, arguing the cargo simply degraded on its own. Addressing the thermodynamic flaw requires an architectural fix. We can physically isolate the cargo from the internal microclimate and use environmental data to challenge the inherent vice rejection. Step 1 begins at the loading dock. This is the primary choke point where catastrophic moisture variables are accidentally loaded right alongside your product. Porous materials like standard cardboard absorb ambient humidity and slowly release it over the voyage. To lock down the dock, we enforce a strict preload protocol. You must check the container floor for moisture content, inspect the ceiling for light-leaking pinholes, and verify the physical condition of every pallet. Loading standard non-kiln-dried wooden pallets introduces gallons of hidden water directly into a sealed steel box. The heat of the day will bake that moisture out of the wood and into the ambient air. Once the container environment is verified, we have to match the isolation architecture to the specific regulatory and physical requirements of the payload inside. This logic model maps 2 distinct isolation paths. On the left, heavy machinery requires rust defense, focusing purely on keeping water off metal. On the right, pharmaceutical goods demand strict chemical stability compliance, meaning both moisture and temperature must be regulated to prevent ingredient breakdown. The scale of industrial exports makes this critical.
Look at the exposed surface area on heavy machinery, like these tractors. Even minor surface rust on components like this can lead to rejected deliveries and remachining costs. Stopping ambient moisture at the loading door and defining exact commodity tolerances are mandatory prerequisites. You have to establish a clean baseline before you deploy any physical barrier. This graphic illustrates the failure mechanism of standard silica gel. It absorbs moisture when the air is cool, but releases that water vapor right back into the container once temperatures spike. Its effectiveness is limited to a narrow temperature band. We replace silica with calcium chloride desiccants. Calcium chloride aggressively pulls moisture from the air and permanently traps it as a viscous gel, regardless of temperature swings. Next, we deploy engineered isolation. High-value goods go inside Mil Perf 131 moisture barrier bags. These are military-grade foil structures designed to block both water vapor and oxygen. By vacuum sealing the asset inside this foil barrier, we strip away the ambient air entirely. We separate the hardware from the chaotic environment outside. Maintaining this sealed barrier allows manufacturers to extend the rigorous cleanroom standards of the factory floor directly through the international supply chain, maintaining total regulatory compliance. Combining active calcium chloride with a vacuum-sealed barrier shifts the logistics strategy from passive hope to mathematical isolation. The physical barrier protects the cargo. But to protect the balance sheet, we need continuous telemetry to prove the environmental conditions inside that barrier during the voyage. We install a low-cost Bluetooth low-energy data logger. The placement protocol is strict. The sensor goes inside the barrier bag with the asset, not on the exposed container wall. Over a 30-day ocean voyage, the sensor continuously captures the temperature, the internal relative humidity levels, and the final dew point calculation. This localized data provides an immutable ledger of the cargo's protected state. When an insurance adjuster tries to blame the damage on the nature of your product, you provide the environmental ledger. This graph maps the JSON payload. The red line tracks external temperature. The blue line is internal humidity. Where the red temperature line crosses the blue dew point line is the moment of thermodynamic failure. Condensation occurs. Hard telemetry data moves the dispute into technical territory. You stop arguing over assumptions and start presenting a documented record of the container's internal performance to the carrier. You do not need to disrupt your entire enterprise supply chain overnight to implement this. We use a phased rollout to safely test the architecture. Your 48-hour validation signal is simple. Apply the foil barrier, the calcium chloride, and the telemetry protocol to a single high-risk out-out container. This comparative chart shows the exact destination payload data. We can clearly see the volatile humidity spikes of the standard shipment on the left, contrasted against the stability of our isolated test container on the right. Proving the concept on a single trade lane gives your logistics operators the concrete data they need to build the business case. Once proven, you can standardize the protocol across global exports. Look at the volume of global transit. Millions of metal boxes sitting on docks, subject to weather patterns and rapid temperature shifts. Leaving high-value assets exposed to this environment guarantees continuous financial loss. By implementing this system, your loading dock is secured, the physical cargo is isolated, and transit conditions are mathematically proven. We stop absorbing the cost of ruined shipments. We equip logistics operators with the tools they need to enforce accountability. Precision engineering requires a packaging architecture that can survive the voyage. You can download the raw loading dock checklist and the IoT data templates in the description below to secure your next shipment.